Welcome to Ask and Learn.
We're given a differential equation and a point in the plane, and we're asked to find the slope field of this equation and to draw the graph of a solution which contains this point. The differential equation is y prime equals x plus y squared, and the point in the plane is the origin, 0, 0. Find the slope field of this equation. Suppose c is an element of real numbers, and that y prime is equal to c. Then it follows that c is going to be equal to x plus y squared, so that x is equal to negative y squared plus c. And you can think of these as horizontal parabolas that lie on the x-axis facing towards negative infinity, and which have an x-intercept of 0, c. And we have that all points on this parabola will have slope c. So, start by drawing my x and y axes. I want to emphasize the negative side of the x-axis, since that's where most of the parabola will be. So in particular, if c is equal to 0, then we have x is equal to negative y squared. So we have a parabola which has a point at 0, 0, and also has a point at negative 1, 1, and negative 1, negative 1. And all along this parabola, the points have slope 0. If we take c to be, say, 1, then we'll have x equals negative y squared plus 1, and we have a point 1, 0 on this parabola, which has a slope of 1. We also have the point 0, 1, and 0, negative 1. And all along this parabola, points have slope of 1. And this parabola lies just outside our first parabola. And we see that as c gets larger and larger, our slopes are going to get steeper and steeper. And so we get these shells of parabolas which get steeper and steeper slopes. And the slope is still always positive, although it becomes nearly vertical, further and further we move towards infinity. Now, if C is somewhere between 0 and 1, we're going to have a parabola, but its slope will be between 0 and 1. So in between the slopes of the two parabolas, nesting it. If C is going to be less than 0, then the slope is going to be less than 0. The parabola will have its apex at point C less than 0. So again, we'll have a series of parabolas nested within each other, for which the slopes are gradually decreasing. So we see that as we get further and further away from towards negative infinity on the x-axis, the slope fields are getting steeper and steeper to the point where they're nearly vertical on that axis. So this is a rough representation of the slope field. This will make it a little more complete. Okay. So it's really just a bunch of nested parabolas which get thinner and thinner, and the slopes get more and more negative as we go towards negative infinity on the x-axis. Point 0, 0, the origin is contained here, and you see that as we approach positive infinity, following the tangent lines, our function increases towards infinity, sort of exponentially, and as we approach negative infinity, it's a little bit tricky. So along the x-axis, we have x is equal to 0, y prime is equal to y squared. Okay, if y is equal to 0, we have y prime is equal to x, or that, taking the integral of that, y would be equal to 1/2 of x squared. So, the more negative we get, steeper and steeper the slope gets. So essentially what we have is incredibly negative slopes limit as x approaches negative infinity on this function simply be y is equal to 0, we have y prime is equal to x, so that taking antiderivatives, y is equal to 1 half x squared plus c for some c in the real numbers. Now, we know that we have a point 0, 0 in this solution. So we're going to take c to be 0, y is simply 1 half x squared, and so we have that the slopes at these points, y prime, is going to be x. So that the further you get away, the steeper the negative slope. Essentially, this means that the function is getting pushed upwards until it reaches a point where it reaches a zero slope, and then it's beginning to be pushed downwards again. So this is one direction that it can go. Another curve that's equally possible is, instead of going up, you go down and follow this other parabola, which has slopes of 0. And on the other side, this is actually not true. Okay, so this actually has to go up.